opinions expressed in this show belong to the person expressing them. They do not purport to reflect the opinions or views of Rancher or any other entity.
All right. So today was going to be a show where I controlled my own fate because I wanted to have the schedule. Thank you, Dirk. I wanted to be able to schedule the poll so that people who were watching on YouTube or after the fact had a chance to vote, join the community, et cetera, et cetera. And so today's show is going to be a little different than normal, but I think it's still going to be pretty valuable. So one of the things that I've aimed to do since I started kind of tooling around with the tools of the day is make it so they're quicker and easier for people to play with, and so that people could just so they don't have to worry about the infrastructure or the substrate that they're built on top of. That's a very complicated process considering how we're just a random community of people that are volunteering or just signing up together. There's no vetting process. There's no assumption that people are running a Kubernetes cluster. There's no assumption that they're accessible from the internet. So there's a lot of I tried countless different approaches to get people Kubernetes environments either on their home machines or in public environments in a way that they feel safe and secure. And ultimately, this is where I landed. So without further ado, the tools that we're going to talk about today, as I outlined, or as I think Adrian mentioned in the tags for the YouTube videos and the stream, are going to be Fleet, which is a GitOps operator. So we're going to have the tool of the day stored in GitOps, and then you're going to have your cluster register with that Fleet, and then it will get the tool of the day deployed to it automatically. The problem that I ran into there is that Fleet, since it is going to be deploying Helm manifests, it doesn't necessarily know which namespace they're going to go in, which resources are going to be deployed there. So it's going to require elevated privileges, and I didn't want to ask all of you to give me root access to your admin, to your clusters, regardless of whether or not they're throwaway cloud instances or if they're on your laptop. I didn't want to take on that responsibility. If I deployed a tool of the day to your environment and your whole laptop blew up, I didn't want you guys knocking on my door. And as Adrian mentioned yesterday, getting some nice messages from the community. Not that popular yet. So the solution that I came up in conjunction with Fleet to work around the permissions issue is something that's been mentioned a couple times before, but it's the virtual cluster. So a virtual cluster effectively is going to be a tool that allows you, yes, please no death threats. A virtual tool or a virtual cluster is going to install API server components that are essentially proxying with the API server of a wrapping cluster. And so you'll still have permissions. This Fleet agent will still have permissions on that cluster, but they'll be designated to a namespace. So it's an interesting situation, and I'll try to explain that as best as I can. And I'll also try and follow the Discord chat as closely, because this is going to go over some interesting, not so standard ideas. And hopefully we'll get to the point where you guys could maybe later after the show DM me, and we can start working on ways to make so that I can either send tool of the day to you or make tool of the day available to you, so that in later episodes, like let's say if I'm going over the policy reporter from yesterday, you guys can start on the show, maybe make a Discord /command. I might have just propositioned myself to the community. We'll see how that goes. I'm getting distracted by Discord. I'm reading it, but I'm getting distracted. Also, anybody who posts what about just making a container to download? I mean, that would work as well. That would be probably a much more secure way, but I don't know. I like the shiniest and the best tools, and I wanted to make it available within a full cluster environment so that you have the ability to just run. Yeah, exactly. Adrian just said that that's too easy. I will never go for the low-hanging fruit. So without further ado, I have a working example of this that I'll walk you through, and then if time permits, we'll have the ability. I'll show you how it would work in a couple situations. So I have on one of these windows, this cluster. I have a Rancher instance and I have an Arc8 government instance. They're both being hosted in DigitalOcean just because that's my cloud provider of choice. So in this instance, if I click on Explore, we will see a couple of things within this environment that I want to point out first. The first thing is that in the apps and marketplace, I've associated a chart repo. That chart repo is for virtual cluster. It's my own fork of virtual cluster, as you can see here, but it's using the loft-sh virtual cluster repo. The reason I forked it is because I wanted to make some changes to the default values of this chart, but and maybe sometime I'll push it back, who knows. But for the most part, this repository is just going to ask you to find the service CIDR for your Kubernetes cluster. And once you find that service CIDR, you're just going to paste that into the Helm chart values and then run a simple Helm chart command. What you get with a virtual cluster is if you go into chart, let's look at the values first. These are going to be pretty small, so I'm going to make them much bigger. There are 2 pods that get deployed, or there are 2 containers that get deployed in this pod. There's the Synchro pod, which I found out contains much of the magic of what Loft is doing here with virtual clusters. You can see here there's an extra ARG that I personally pasted in so that I can do some proper certificate encryption with the right SANs. There's a data mount because K3S is going to want some directory to store things in, and maybe you want some persistence between these virtual clusters. And then there's the virtual cluster itself. The virtual cluster is going to be, as you can see, just a K3S image. That K3S image, though, is going to have a whole bunch of things stripped out of it. So you'll see here that we're disabling Trafic, disabling Service LB, metric server, local storage, network policy, agent scheduler, cloud controller, flannel, and then of the kube controller manager, we're doing all of them minus node IPAM, node lifecycle, persistent volume binder, attach detach, persistent volume expander, and cloud node lifecycle. The one that I've kind of earmarked for later that might be a problem because we often talk about network policy here on this chat. That's a good question, Dirk. I don't know what's left after that. I'll have to look in and see what the full list includes. But the thing I'm going to see if I can wiggle back in is the disable network policy, because there's going to be a lot of tools that are leveraging the network policy. And then here you can see that the extra args I've already put in the standard, the default service CIDR. I'm using 5 gigs for the storage. And one thing that I will point out is just because I wanted to make it as easy as possible, the cluster that I will be running these virtual clusters on, where did that go, is also running Longhorn. Longhorn is another Rancher product. You don't have to use it. I'll just be using it because I'm familiar with it. It's just going to make block storage available to the cluster. So that whenever I create a persistent volume, it'll just automatically get taken out of the node's disk. So now, if we look at the Helm chart that was installed, we'll see that one's not installed here. It's on, this is the wrong cluster. Installed apps. We'll see that I do have a virtual cluster 0 being run. The virtual cluster 01 it says chart 01, but I did have to make a change because their chart value was using .0.0.1 of their Synchro image, and it just wasn't working. I couldn't find the source code for the actual image. So if anybody knows where that is, let me know. It might not be open source. But I was able to play around and look at what the binaries are and make some changes based on what's in the container. If we go back to the cluster where we have virtual cluster 0 installed, I'm going to go back to the cluster manager just because it makes a little bit more sense visually speaking. And we go into the default namespace. You can see, well, I guess there's still a lot of confusion here. We can see let me actually, no, I'll keep it the way it is. So the things that are important here are this virtual cluster 0 with that generated number. That's running that Rancher K3s pod. In that pod, you can see there's a sinker and a virtual cluster, K3s and virtual cluster 022. And then additionally, the other thing I want to point out is that each one of these is going to be leveraging a core DNS pod, which is going to allow you to handle the network translation. Zoom browser window and a couple of clicks, please. Oh, okay. Thank you, Adrian. Yeah, that's a little bit too hard to read. So beyond that, if we look at the actual cluster, you can see that there's a port down here and a protocol. I changed the Helm chart such that it's giving you a node port, because my ultimate plan for you guys is that you'll be able to just scrape off virtual clusters off of my global cluster. They'll already have the tool of the day installed on them. They'll be set up to self-destruct after a certain amount of time. And then you'll be able to play around, and then you'll get the full value of what the tools are purporting to do. You notice there's also a headless service. I didn't drill into too much as to why they had separate services. I might do that in a little bit just to make sure I have a full understanding of the project before I go any further. But the one thing I want to point out is that if we click on this link and we make it secure, we'll see a standard Kubernetes API request. So Loft has smalls. The virtual cluster repo is the one that I forked. That's for the Helm chart only. I wanted the source code for the container that's running the sinker pod, or the container that's running in the sinker configuration. With that being said, having just the access to that endpoint isn't enough for what I intended to do. If we go back, I'll keep navigating weirdly, go back to the workload. The next step would be to get that cluster to have workloads automatically deployed to it. And like I mentioned previously, that would be done through Fleet. So I should probably take a step over here to Rancher Fleet docs. We'll go over here, and I want to specifically go to this link, operator guide, managing clusters, registration. So the idea that I had is that I wanted to go through and, with as little configuration as possible, have these clusters automatically join the fleet that's running on the same cluster, the fleet manager that's running on the same cluster. So the way to do that, I looked through the agent initiated. The agent initiated mode is going to require a token. And so there'd be an additional step to add a token. And I didn't want to do that. And then I looked at the manager initiated. And what the manager initiated really needs is just the kubeconfig secret. The kubeconfig secret, as you might be able to expect, is being generated by that K3s cluster. And so we just needed to make that available or bubble that up to the parent Kubernetes cluster level and make that happen. So if we go back to this Rancher environment and we look at, let's look at the deployment itself. If we view edit YAML, I apologize in advance for all of the YAML. Manage fields, manage fields, manage fields. But the important key value to notice here is that the virtual cluster is writing the kubeconfig to a designated directory, K3s config -kubeconfig. So technically, I could do some trick mouse and then scrape that off of a persistent volume. But I did also notice that the loft.sh is making that kubeconfig secret, kubeconfig configuration available as a secret. So you can see here that this secret matches the value of that K3s cluster. And then I'm going to have to delete this cluster afterwards after I show this. Let's see that it shows localhost though. That's the problem that I still have to work around. But once I did that, we just needed to bring that kubeconfig secret to the Rancher instance on the same cluster. And what better way to do that than our recently best friend, Kyverno. Kyverno has the mutating admission webhook configuration. So when Loft tries to create that secret, Kyverno will see with the mutating admission webhook, which I'll show you the cluster policy. The cluster policy is, let's make sure I'm in the right environment. Cluster policy is here. Cluster policies, yep, that one is 10. The fleet policy. That fleet policy will take the secret from the mutating admission webhook and then create, with this generate function, a cluster object, which is how Rancher is going to interpret the kubeconfig file. And so just to prove that that's working, if we look in the continuous delivery, we can see that there are two clusters. There's the imported cluster, which is the cluster that's already associated with the Rancher, but there's this test remote cluster. And in this test remote cluster, you can see, I guess we're not going to be able to see too much with this. Yeah, you can see that there's a client ID and the kubeconfig is pointing to the test remote secret. And that's what I did with the Kubernetes policy. And so at this point, since it will automatically join to the Rancher instance, it will then get all of the Helm deployment from this configuration. And I've already got a Git repo set up. So let me go through, I think I've got enough time, and show you the process from start to finish. So if we go back to the apps in Marketplace, let's install the app. Let's go to a new chart, virtual cluster. I think I can put this in. We might need to do some manual stuff here, but bear with me here. I will have it automated for use in the community later. The values you can see, there's going to be that TLS SAN. That one is going to still be valid here. Okay, so step number one. I probably should have scripted this out beforehand. Peter gets a point. I'm not saying that that's true, but I really like that GIF. Also, Talladega Nights. So in the apps and Marketplace on this cluster, I'm going to install another virtual cluster instance. We're going to see that the values, this has the TLS SAN, and this address is associated with this cluster. So I'm going to click install here. That will install a virtual cluster. If we go back to the cluster manager, because this is starting to get a little bit clouded, and go into the default namespace where that's being deployed, we will see the virtual cluster. That virtual cluster first has to wait for the volume to be created. We can see the second one got created for that workload. That virtual cluster is up. Usually there's just a little bit of a hiccup there. That virtual cluster now has virtual cluster and syncer active. If we look at the logs of the virtual cluster, the main thing we need to find out, internal IP is an issue here, but that's not something we need to be concerned about. The K3 has started successfully. There should be a log message in here somewhere that says that that has a response to that regard. Going back to the workload, we can see that if we click on this link, and again, make it HTTPS, advanced, proceed, we'll see that that's the standard API service. Then, like I said, we will look at the secrets. There's that generated secret here. That generated secret, for now, this is going to show you the manual process. But if we look at this guy, edit, Control A, Control C, we will import that into this local cluster, into a specific namespace, resources, secrets, add secret. We're going to add that to the fleet default namespace, test. So let's just go say a live demo, value, dump that in there, we will say that we need to go to, I believe it's this one. Nope, this guy. I'm really just grabbing the port here. If we, well, lost my, there we go. pc.state of KS.com. That should be a properly resolving kubeconfig. We will save that as live demo, and then we will create the cluster, well, which would have been created with Kyverno. I just don't have it set up to automatically do that right now. We will create the cluster, which I have an example chain directory. Let's make this bigger. I have cluster. The secret that we need to refer to is live demo. Let's also name this live demo. Make sure that I'm referring to the proper cluster. kubectx local kubectl get nodes, just to double check that I'm running on the right cluster. And we will then kubectl apply f cluster.yaml. And then ideally, at this point, assuming everything's right, we should have a virtual cluster that has the fleet associated with it and fleet deployed to it. So let's test and see what we have. Over to the local cluster, if we look at the Explorer, and we look at continuous delivery, we can see the third cluster. The cluster was just checked in that cluster. Live demo. The live demo just has six deployments in it. And then now let's check in with the virtual cluster's kubeconfig and see if it gets everything it needs to get. If you recall, the easiest way to get that is with the secret that's generated, which I lost in one of these browser tabs. Let's go into Cluster Explorer, secrets. Secret is, I'll filter through V0 or VC. Oh no. I'm in the wrong namespace. Let's go to fleet default, live demo secret. Stay with me, guys. The idea of the show is that all of this is going to be done automatically, so you don't have to worry about it. But it's really, really cool in my opinion. So I take that, copy that secret. We will vi config.amp or config. Kube config equals config. kubectl get nodes. Fingers crossed. We have a node. The way that the virtual cluster refers to nodes is a little interesting. You might want to look into it. kubectl. Let's go back up here for the money shot here. Clear. There we go. This is a virtual cluster that I just spun up. And now it's got core DNS, it's got fleet system, and it's got all of the tool of the day that we wanted to talk about. And since this is all done, I figured out how to trace the crumbs all the way back up to the system, or all the way through an automated system. I should be able to give this to you guys, maybe not by next week, but eventually in the next couple of weeks, so that prior to an episode, you just have to essentially pull down a cluster. You can play around with the tool with me, and that way I can see how you guys are going, what you guys are doing, what you guys might want to do with the tool of the day, and we can start to do something a little bit more interactively. With that being said, let me see if there's anybody have any comments, questions based on what they saw. I know it was, I wouldn't say that it was strictly easy. It will be easy because of the automation, but there's a lot of interesting tools along the way. And the main part that I want to point out is that this is to work around the security issue. So you'll be able to deploy either this in your environment if you deployed virtual clusters in your environment without worrying about me deploying something that's going to break your home laptop or your home Kubernetes. Or you could just take a free cluster off the internet that's going to probably be hosted off of CNCN.io. But beyond that, I guess, thank you for watching. Look forward to more on this. If you haven't answered the poll for next week yet, please answer that. I'll post another poll after I close that. I'll probably close that poll tonight. And beyond that, I'm going to say have a great weekend. Thank you for watching, and stay caffeinated.